The James Webb Space Telescope is the next premier space observatory. It will extend the discoveries of the Hubble Space Telescope and observe the birthplaces of planets, stars, and galaxies. It is named after James Webb, NASA's second administrator and champion of many NASA science missions. At 3 stories high and the size of a tennis court, this will be the largest telescope ever sent into space, and 100 times more powerful than Hubble. It is so big it has to fold to fit into the rocket only 5.5 meters wide, and unfolds segment by segment once in space. Webb's mirrors are coated with a super thin layer of gold that is about 1,000 atoms thick to optimize their reflectivity in the infrared. Webb will launch from French Guiana. It is launched near the equator, taking advantage of Earth's greater rotation speed there to boost launch performance. Webb will orbit the Sun 1 million miles from Earth at the second Sun-Earth Lagrange point. The telescope will observe infrared light with unprecedented sensitivity. It will see the first galaxies, born after the Big Bang, over 13.5 billion years ago. Webb's infrared cameras are so sensitive, they must block light from the Sun, Earth, and Moon. The 5-layer sun shield is like having sunblock of SPF 1 million.
The more distant in space we look, the further back we're looking in time. And so we're designing the James Webb Space Telescope to see past the point where Hubble could see, and to see the very first stars and galaxies to light up after the Big Bang. The James Webb Space Telescope is designed as an infrared telescope because infrared is really where the key science questions will be answered. To see those very, very distant galaxies, the light from those galaxies has been redshifted. The expansion of the universe sort of stretches space-time. The light from the galaxies gets stretched as well. And so longer wavelengths of light are redder. And so at some point in the very distant past, the light from those galaxies has been shifted, redshifted, all the way out of the visible spectrum to the infrared part of the spectrum. So having an infrared telescope in space is one of the things that's going to allow us to see those very first galaxies. One of the key things that the James Webb Space Telescope is designed to do is detect the very first stars and galaxies that were born in the very early universe. So this is a part of the universe that we haven't seen at all yet. We don't know what's there. The more distant in space we look, the further back we're looking in time. With Hubble, we're able to push back and see pretty far into the distant universe, but we do reach a limit. And so we're designing the James Webb Space Telescope to see past the point where Hubble can see, and to see the very first stars and galaxies to light up after the Big Bang. We know that there is a time in the universe's past where the galaxies were the first to light up. Basically, the stars and the galaxies send out ionizing radiation, which clears out the fog of the hydrogen in the universe. And so once that hydrogen fog is cleared out, then the stars and galaxies can shine through. And so getting to that point, just beyond what we call the dark ages, is one of the major goals of the telescope. That whole process of galaxies forming and evolving over 13+ billion years, we've learned a lot about that, but we're really missing a key piece of the puzzle, which is how galaxies got their start. So that's the piece that we haven't seen yet, and that's the piece the James Webb Space Telescope will allow us to see for the very first time.
So the first stars and galaxies are really the big mystery for us. We don't know how that happened. We don't know when it happened. We have a pretty good idea that they were very much larger than the sun, and that they would burn out in a tremendous burst of glory in just a few million years, which is really very short. But they would also prepare the way for further generations of stars like the sun to be formed. So those first stars would produce the chemical elements of life, carbon and oxygen and nitrogen and iron and sulfur and calcium and all the things that we're made of would have been produced in those first generations of stars that then explode and liberate the material back out into space. So the next generation of stars could form with planets with solid bodies and possibly have life.
Another one of the big goals of the James Webb Space Telescope is to see how planetary systems got their start. So that would be akin to thinking about how our solar system was several billion years ago. So looking at the big disks of gas and dust that eventually form stars and planets. Another really great thing about Webb being an infrared telescope is the fact that a lot of the really interesting components in a planet's atmosphere happen to fall in the infrared part of the spectrum.
When a star has a planet that goes in front of the star and blocks some of the starlight, we can say, now we know how big that planet was. And also we can begin to explore the light that goes through the planet's atmosphere on its way to our telescope. We spread that out into a spectrum as well, and we can say, now I can see what are the chemicals in the atmosphere of another planet.
So for example, we can look for things like water vapor or carbon dioxide, those types of things. So the Webb telescope is definitely our next step in our search for life in the universe.
Webb is an international mission with contributions from the European Space Agency and Canadian Space Agency. Scientists all over the world will be able to use Webb to explore further into space and back into time.